All right. Well, good afternoon, everyone. Welcome to the Scott Institute for Energy Innovation. My name is Daniel Tatchik, and I'm the executive director here at the Scott Institute. And we are just so excited to have you all here to hear from a current CMU postdoctoral associate and a clean tech and climate tech entrepreneur advancing a very exciting company that you're going to hear about. But before we get to today's speaker, in case you're unfamiliar with the Scott Institute, we are CMU's campus hub for all things energy. We give out seed funding each year to help grow new energy, clean energy research. We provide support for new energy initiatives campus-wide. We also provide support for our startups in entrepreneurship. We've supported the company that you're going to be hearing about today. And we host many energy-themed events such as today's Entrepreneurship Lecture. So really at the end of the day, what we truly care about is encouraging the development of breakthrough technologies, systems, and policies that accelerate the transition to a sustainable net zero future. And if you aren't already subscribed, if you came in the door, saw the registration table with the QR code, pull out your phone. This is the #1 way to know what's happening on campus related to clean tech, energy, innovation, research, anything energy related. We don't spam you. We know emails are crazy. People's inboxes are exploding. Mine is at least. So we only email you once a month, and it's the best way to know what's happening across campus. And if you need other ways to get in touch, we're on LinkedIn, X, and the web. And so, without further ado, that brings us to our main event and speaker. Dr. Hyderkhan is a materials innovator and energy entrepreneur at CMU, where she designs custom reactors using advanced semiconductor-based chemical and physical vapor deposition techniques. I got through that sentence. As a co-founder and founding engineer of SeaLion Energy Inc., she is leading the charge to revolutionize and improve battery safety and lifespan for electric vehicles, aviation, and grid storage. Her research and startup has earned a respectable amount of support from ARPA-E, from the U.S. Department of Energy, CMU's very own Scott Institute, in close partnership with CTech, I must add, and Innovation Works Pittsburgh. She was also named a 2023-24 Innovation Commercialization Fellow at CMU's Swartz Center for Entrepreneurship. So, please join me in welcoming today's speaker, Dr. Renuka Hyderkhan.
Well, Daniel, thank you for the introduction. It's great to see you all here. As Daniel mentioned, I'm a postdoctoral research associate in the mechanical engineering department. I'm also the founding engineer at SeaLion Energy. I believe I've been invited here today to talk about my experience and my journey as an entrepreneur here at CMU and going forward. And so before I start off with my talk, I would like to know how many of you in the audience are undergraduate students? Okay, how many of you are masters? Oh, that's nice. How many of you are PhDs and postdocs? That's great. All right, so this will help me to add anything else additionally to the slides that I've prepared. Thank you so much. Today, it's going to be a fun agenda. I'm going to kick off the talk by giving a little more background about myself, why and how am I here today, and then my journey, the programs that I've been through, and then my experiences. Then about SeaLion, the company, of course, a deep dive into what we do and what we're building here in Pittsburgh. And then some Q&A, and I'm happy to answer any questions. So before joining CMU, So before joining CMU, I was, the animation is not working, but yeah, that's supposed to be a video. But yeah, well, I was in India, in a small city called Hyderabad. I was doing my PhD at Birla Institute of Technology and Science. So if you see here, this is my professor. He's my advisor, Professor Sanket Goyal. That's my mom there, if you can see here. So this was a previous visit to my lab after graduating. So we had a huge lab. My professor was well known in the semiconductor community. So we had a lot of projects. If you can see here, there are around 20 to 30 students in the lab. And so we were working on different verticals. So of course, 30 students, 30 projects. So we were working on MEMS, microfluidics, sensing, energy harvesting, energy storage. So I had a lot of scope to experiment, to kind of collaborate, right, learn. And so this is just what is a snapshot of what my research was like. So I started my PhD by exploring various materials and how to engineer them for energy harvesting. So I was one of the first authors to introduce 2D materials and latest magazines and some stuff into solar harvesting, like photovoltaic PVs. And then I expanded my research into semiconductor thin film deposition techniques using chemical vapor deposition, PVD, vapor phase deposition, and so on and so forth, and a lot of nanotechnology. I was building materials at nanoscale. And by the end of my PhD, I was doing more of flexible and wearable electronics as well. So if you can see here, I was doing a lot of things which kind of laid a foundation, technical foundation of what I would be doing next in my postdoc. But then along the way, I was also realizing that even the most exciting ideas in the lab always stay inside the lab. Right? So this thought kind of stuck with me, that what can I do? How can I contribute so that these breakthroughs in the lab go into real world impact, right? So traditionally, after graduation, people take two paths. The first one is going to a teaching job. So most of my colleagues in the lab went and took a teaching job. They were like doing tenure track positions, research positions, but I didn't want to do teaching. At that time, I was looking for something else. And then, so I wanted to go work for a big manufacturing R&D company, like a foundry, like a, chip making company. But in India, the problem is they were packing and testing, but there was no integrated device manufacturing, especially in the advanced 3 nanometer, 5 nanometer nodes. So I was thinking, okay, what if I go do a postdoc in the West, get some experience, then this will enable me to go work for big companies like Intel, TSMC, and so on and so forth, which basically do the semiconductor technology, right? So that was my route to CMU. Okay, that was supposed to turn as well. So I traveled from Hyderabad to CMU, right? And immediately within 6 months, I joined in September 2022, and I think within 6 months, I entered the boxing ring of entrepreneurship, right? So I was I was asked by Rija to come and join SeaLion, and I was first introduced to Reed McManigal, who was our mentor in residence, and Jake Greenberg, who is our licensing manager at CTech, right? So this was the first interaction, and I think we've always maintained the same CTech collaboration throughout. So you will see hearing about Reed a lot of times. So yeah. So what CTech does is it manages our inventions. It helps filing our patents. They also do evaluations on our technology. And if they see a feasibility of, like there's a commercialization potential in that, they will also help us to license the technology out for commercialization. So this was a big step for us. We had an IP, we had a patent approved. So why is the IP important? Does anybody know why is the IP important? Because it protects your innovation, right? It protects what you're trying to build, right? So that's the laying foundation, like that's your starting block. So we were there, we had an idea. I don't have any entrepreneurial experience. I was just a pure academician. Nor Rija. She has been a full-time faculty, right? So we've never done like going and pitching. We don't know how to raise money. So the second program that we were introduced to is the Chevron Studio program. So this is a great program. It takes ideas, and if there is a potential, it will help you commercialize this. So we were one of the 2 teams selected out of 300 entries from all across the US. And what Chevron does is it allots an external entrepreneur, because obviously I've never done entrepreneurship before and I just have an idea, right? And then they work with you, and there's also another lab called National Renewable Energy Laboratories. So they work with all of us to kind of prepare a go-to-market strategy, right? So they give you time, you can kind of sit with them and then talk to customers, do a bit of customer discovery, and then you come up with a go-to-market strategy. Now what happened, so our entrepreneur, okay, we came up with a go-to-market strategy. We went and submitted that to Chevron. They said, okay, we like it. Take $2,75,000 for the next phase, right? So, okay, then we understood, okay, we have commercialization potential. We have a good idea. Now we have to start raising money, right? So that is when I applied for my next program, which is the Innovation Commercialization Fellowship. It is a great program. It's done at Project Olympus, and it's done again in collaboration with CTEC and Schwartz Center, right? So what ICF does is it will train a PhD or a postdoc, right, to launch your own company, right? So it will make you from an academician to an entrepreneur, right? It will give you all insights into how to do, or how to start with a basic hypothesis, do customer discovery. They'll also encourage you to do ICOR programs, which is very essential to understand who your customer is, what are their pain points, how do you solve them, and they also give you resources and encourage you to write SBIR, like the Small Business Innovation Grants. So all the resources are here on campus as a part of Schwartz Center. This is just one program, but there are a lot of programs that, as an entrepreneur who has just an idea can go and tap into, right? So this was kind of a big revelation for me. I learned a lot of knowledge, right? A lot of learning here. And also I did the NSF ICORPS because I come from a battery background. That's what the company is about. I did a battery cohort at Cornell as a part of my NSF ICORP. So which again gave me a lot of contacts, right? I went and talked to the right people to understand what's actually lacking in the market and how can I fit our product and bring a solution to all the problems related to battery, right? So now that I've known everything, I have to go out and start pitching, right? I have to go out and raise money. So we have written the SBIR funding in around 2024, and yeah, they liked the idea, and recently we received $1.6 million, almost in the start of January 2025, to scale our technology, right? And so we are currently raising money along with building our tech, developing it further, reaching out to customers, right? So in that process of scale up, as Daniel mentioned before, Scott Institute also invests in clean tech and energy by seed funding and through partnerships. So that's how we started again working with Scott Institute and Alpha Lab Care through other programs. So yeah, we are currently, this is the status, and we're still building tech, right? We are gaining a lot of traction. So yeah, I hope this slide kind of gives an idea of what are all the programs that I have done to reach this, at least the seed and the build-up stage. So right now we're doing a lot of R&D development, and yeah, soon we'll be scaling up to commercial scale. So these are some of the pictures that I wanted to show you from the program. So another great thing that I forgot mentioning was that ICF provides an entrepreneur in residence who are like real entrepreneurs. They have already built companies, they have generated revenue to come in and then mentor us during the program. So this has helped me a lot. So this is like a one-on-one session every week. You can go out and talk to the EIR. Sean was my EIR actually, and we had great interaction starting from how do we register a company? Should it be a LLC? Should it be an incorporated? So starting from legal stuff to the more complicated stuff. So everything was organized, and it was great. Interacting and gaining more knowledge. So this was from the NSF battery cohort. We went and pitched at Detroit Battery Conference. This was at the recent pitching event. It was called Invent Penn State. So once you are ready, you can go out and do these investor pitches, elevator pitch, customer pitch, depending upon the time you have, right? And again, you can see Professor Rija also giving a talk, a pitch at ARPA-E recently, right? So coming to SeaLion, and let's see what we do, right? So at SeaLion Energy, we have developed a coating technology for batteries that it can extend the cycle life by 10x. So when we did the customer discovery, one thing was made clear to us, that the battery failure means downtime and replacement costs. What feedback we got was at least a 10 to 20% increase in cycle life would actually save millions of dollars in logistics, in replacement costs, in recycling, right? But because recycling is an expensive process, you can't just throw away these batteries into the trash, right? Because they are not good for the environment. So recycling is expensive, and it's also not streamlined. I don't know if you know this, but the black mass variability, and these batteries, they get just trashed irrespective of their state of health, regardless of their lifetime, right? At what stage of deterioration they are in. And also the minerals to be sorted, it's really complicated. So, and these batteries contain critical minerals like lithium, cobalt. Right now, their prices are soaring because of disruption in supply. That's real, right? And a lot of things, geopolitics, et cetera, right? So this is not just affecting the EVs. It's not just affecting any clean technology. It's affecting us in the long term, right? So long-term problems need long-term solutions. And for the data centers, the batteries can act as an instantaneous backup, right? They can charge during the off-peak hours and discharge during the peak hours, which can save millions of dollars in operational costs. Now, why does a battery die? Why does it just end, right? So I just talked about critical minerals. These critical minerals which go into the battery, due to repeated use, repeated charging, discharging, they crack, they undergo mechanical degradation, right? And then sometimes you can also see that if you charge and discharge faster, risk of fires, right? So there can be many reasons, right? The solution that we bring to this problem is the coating technology that we developed is a conducting plastic at nanoscale. So these plastics, which go onto these powders, they act as a shrink wrap, right? And they help these powders from degrading mechanically, and they also enhance conductivity. So as a result, less resistive losses, increase the time they can cycle. So it gives 10x life, right? So here in Pittsburgh, we are building a super battery that can change how we can prevent fires from happening. We can not only improve the life of fresh batteries, but we can also develop coatings in situ which can regenerate dead batteries, right? So we can also enable high energy density and fast charging applications. So we have a library of 70 plus different chemistry and coating technologies that we can generate in situ. So different applications, and altogether we can contribute to the domestic and circular supply chain with greater than 1,000 kilowatt hour per kilogram over the entire lifetime of the battery and greatly reduce the carbon emissions. So yeah, I talked a lot about chemical vapor deposition. So this is a semiconductor-based technology that we adopted for generating coatings. So they're basically conducting plastics, right? So we patented this technology here at CMU. These are 2 reactors that are currently we are using for the production of the electrodes. We also are building new reactors for powder materials. So we are currently at the pilot scale, I would say. We are quickly expanding into the commercial scale. Yeah, so this is one of the electrode active material coating that we do using the reactors. Yeah, so this is how we can think of the coating looks like. So it's really thin, 20 nanometers. We can't even see with our naked eye. So this is chemistry agnostic. Any battery technology, it can be solid state batteries. It can be a lithium battery, right? So irrespective of what the chemistries are, we can do the coating. We can also embed our reactors into the production line without major changes in the assembly line. And as I told you before, we have 70 different chemistries. We also have a battery management system, and we can formulate new chemistries within a week, right? Yeah. So the target customers for us from the battery value chain initially are, we've divided them into 2, which are the material suppliers, like the powder suppliers, the mining companies. And the second one is the battery makers, basically the electrode makers, the battery pack makers. So for the material suppliers, our coating can enrich the functionalities of their powders. And for the battery makers, it can give long life and also more reliability. So these are our early customers right now. We're working with, I think, 5 to 6 customers in the material suppliers, and we're already making prototypes with 2, 3 companies in the battery space. So this is our team. We have a lot of advisors and partners. We are still working with NREL. So yeah, Dr. Rija, she's the founder and CEO of the company. Well, there I am. And yeah, we do a lot of testing with NREL. According to the US ABC standards, they can certify us that these batteries can be used in, you know, various applications, right, like EVs and grid storage. We also work with Dr. Katie Whitefoot here in EPP. We have an advisor from MIT. She's also the inventor of the CVD technology, right? Well, the next steps, so I envision my future to be making an impact in the real world. The question that always, that stuck with me was, how do I make these breakthroughs and translate them into real world impact? So I think I would be working towards that in the future. And I would also like to thank Scott Institute for featuring me in the newsletter 2023. Thank you. Yep. Almost done. So we're up for questions.
Yeah, we have lots of time for questions, and I think this is really an opportunity for all the students in the room to, if any of you are aspiring entrepreneurs, well, we have someone who can say, this worked, this didn't, but also about the technology. I have a quick question to maybe break the ice and kick us off. I love the visual of shrink wrapping the critical materials in the batteries. How does that affect the ability to recycle? I mean, I know you can, but like if I were recycling a plastic bottle and I wrapped it in some other type of plastic, I imagine that would complicate things. But
yeah, but that's in a macro scale. But these coatings are really like 10 to 20 nanometers. They hardly affect the recycling process. We can go thicker, but it depends upon what sort of material that we would like to go to. But it's not going to affect anything because they are passive. They don't have other properties that could affect process. Yeah.
Gotcha.
Yeah, thank you for the great talk. That was really interesting. And I was really curious about sort of the competitiveness of these grants that you applied for. I mean, like you're like one of two out of more than 300 applications. So I guess what do you think set yourself apart and like your group apart in terms of getting funding? And like, did you have an idea of the sort of long-term scalability of the projects from the get-go, or is that something you learned along the way?
So initially, no idea, right? So we always start with an idea, and then we later on either pivot or maybe develop further. But when we first started with Chevron, it was just an idea, and we were already published. So we were always seeing it in a like lab scale. We never knew what would work in the like a commercial scale. But it's the idea, Sometimes like ARPA-E, they only fund like crazy ideas, right? So the more crazier you get, the better, I guess. Yeah. But it always starts with an idea. That's where the seed is, Yeah.
Hi, Dr. Hyderkhan. Thank you for the interesting talk. I was wondering if you could go over some of the biggest challenges, technical or non-technical, that you've encountered during your journey and how you went about overcoming them.
Oh, yeah, that's a great question. I think the biggest hurdle that I faced personally is when I was switching from an academician and thinking like an entrepreneur. I think the shift in mindset, right? Also, the fear to overcome failure, because when you're here on campus, when you're an academician, you're always protected, right, with funding, with technology and everything. But when you're out there and you're pitching, you're alone, right? And I think how to navigate that landscape without, sometimes people pivot. There are also cohorts in my program who realize that at the end of their fellowship that the technology is not current. Maybe it will take some time for them to develop further. So some of them did pivot, right? So I think navigating that, and also financially, you're raising money, right? You have to go there, talk to VCs, angel investors, different people, right? I think that's an independent thing that you have to do. I think I've just left that shell and then went into the real world. I guess that was kind of difficult for me. But now I think I'm more confident to go out there and pitch. I hope I answered your question. Yeah.
Thanks so much for the great talk. I was wondering if you could comment a little bit more about how you went from, organizing the use cases. You had a great slide for some of the use cases, for example, the high energy density for, fast charging.
Yes.
What the thought process or your company's process to sort of take those and move it to the next phase of interacting with early customers? Was part of it serendipity of, how did you sort of narrow your funnel, if you will, to think about your next steps with like strategic partners and early customers?
Yeah, thank you. That was a great question. I think, again, Reed will come into the picture again. So we did a great program with UPIT students, MBA students, wherein they did a lot of market study. What is the total addressable market? What are the cost, limitations for us? Because if we add a coating, how much is the total cost that we are going to add to the total battery pack? So there are some statistics that they gave a really they did a really great study to kind of help us narrow down on what sort of customers that we should first approach, right? And then we narrowed down that EVs are better than grid, because we were thinking, okay, high energy dense applications would first go to the grid storage. But then we started gaining more interest from the EV companies. There's a lot of research going on in the EV sector. So yeah, so we decided based first on that study and also the general pitching. So when we went pitching in San Diego and in the West Coast, a lot of VC firms were showing interest for EV battery technology and development in both cathode, anode, again, recycling, circularity. So yeah, I think that's how we decided that we should first go for EV customers.
Thank you for the presentation. Again, on very similar lines, I think you kind of touched upon it, but what is the exact business model? Are you guys, acting as consultants or going in, putting your stuff in, and why you chose one over the other? If you can just talk on that.
Yeah,
thanks.
So first we had this coating as a service model, wherein we don't know which chemistry or we don't know even if it works on a full battery scale, like electrode scale, or powder, like basic starting materials, right? So we asked customers to send us. We'll coat and we'll send them back. So yeah, so we had a coating as a service model initially, right now. And then as we scale up, so it's going to be in kilograms, right? Hundreds of kilograms. So we have to partner directly with the OEMs or the battery makers to go and install our tech into their production line. So right now we are in the development phase. We're trying to build these reactors so that we can go and install. Yeah.
Hey, thank you for the talk. I'm wondering, what do you see as the biggest advantage of your plastic coating when comparing to the other competitive technologies, for example, like all solid-state battery or sodium-based batteries? How do you persuade the investor to take your idea?
Yeah, thank you for the question. It's a great question. So ours is chemistry agnostic. We can go on any type of chemistry. The advantage that we have over other coating competitors is that CVD as a technique gives us a vapor phase deposition, right? Other companies, they usually do solvent based. They use a lot of solvents and there's a lot of wastage, right? But ours is completely hands off, right? You do everything in the vapor phase, and as a result, our coatings are so conformal, right? So there's an advantage. We've done some studies over this, and why it is better, because they're conformal, they're at nanoscale, they don't break easily, and it's also cheap. Plastics are cheap, right? Compared to graphene or other materials that are being done right now in the market, right? Yeah.
So for any kinds of batteries, you can just apply your plastic coatings to that, and they don't even need to change any of their original setups or
Yes.
okay.
Yeah, it's actually applied at the interface, so it wouldn't be a problem. Yeah.
Thanks a lot. Sounds like a great idea. I've got two questions. One, it sounds like you've already done some preliminary studies. It may be too early to ask about the economics of this, but I see you've got Katie and other high-powered folks. Do you have some estimate of, in terms of full-scale costs, is this still a net cost adder, or when you consider some of the benefits like longevity, does it actually reduce battery cost? Do you have any preliminary numbers about that?
Yeah, so it should be around 1 to 3% of the battery cost. But as a result, if it's enhancing 10x lifespan, we will be saving a lot of money on overall, in the long run. So we were guessing it's around 1 to 3% of the cell cost.
So part
The battery, the pack cost. So
part of your pitch is that it would reduce the long-term costs,
yes.
and you just have to get on that learning curve, right?
Yes.
Right. Okay.
Yeah. I think right now the total addressable market is at 4 billion, but we wouldn't tap, like if it's for everything, if it's for EVs and grid and every customer available. But it's almost 75%, I think, the serviceable market would be at. So yeah, around 1 to 3 billion should be our serviceable market. So yeah, we want to tap into that. Right? Yeah.
Dan just gave me permission to ask one more question. I'm wondering about competition. So if this is a really nice, new, neat idea, have other people already picked up on this? You've got patents to protect your thing, but other people will create other things. Are other people already starting to try to copy what you're doing?
They're already there, but not in, so they're, as I told you, we're doing CVD. They're doing other processes like atomic layer deposition and all that, but they've not yet reached plastics. They're doing inorganic coatings right now. So yeah, this is pretty fresh idea. So yeah, we will be seeing some competitors soon, I guess. Yeah.
So I'm curious, following up on his question, how has your technology allowed your customers to increase margins?
Well,
if it lasts longer, you should be able to charge something more, and there'll be some sort of inflection point there, right?
So I think that we can only know that over time. I think we just 1.5 year, 2 years just started. So even if we run testing right now, we'd just be reaching like 1,000 cycles. So whereas the battery packs would originally run like 10,000 cycles or more. So it's over time that we would know how these would affect the margin of the cost and pricing. But yeah, I think we're still early with that. Yeah, maybe we are getting the question now that we've already started thinking about it. But yeah, I don't know much about long-term pricing and what these battery makers would cost. Yeah.
More of a marketing question.
More of a yeah.
I would imagine there's got to be value there at some point in time. And in a different category, I'm wearing a hearing aid. These things the batteries only last like a day. If you can 10 times that, I'd be super interested in that technology. Sure. And then on a larger scale, could this be transferred to high distribution transformers?
Yes.
That type of technology.
Yes, that's the main traction right now is for the data centers, right? So they need huge backups of power, and they have to be situated right next to the power plant. So doing this, in a larger scale would actually help us bring down a lot of operating costs when these data centers come up. Right. So yes, that's a big market for us. And also talking about we thought about this as a niche market, like the power tools and the kids' toys, and there are other markets that we can also concentrate on apart from like the big marketing sectors. So that's a great point. Like niche markets can also be one way to start working on developing these batteries. Yeah.
Hi, Dr. Hyderkhan. Thanks for coming and giving this talk. You mentioned briefly that when you were in university, you were seriously considering that you wanted to go into the industry. I was sort of wondering what your, if you could reflect on your decision process to make the big decision of going into entrepreneurship rather than going into industry at the time. Was it an easy decision? Was it a hard decision? Did you require any arm twisting? What was that kind of process like? Was it an easy choice or a hard choice? Thanks.
Well, yeah, that's the most difficult question, I guess. Yeah. So, yeah, as I told you, I had this thought always, like, how do we translate these breakthroughs from lab into real world impact? And one of the reasons I said yes to Regia was, when I was asked to join SeaLion, I could make a real world impact if this works, right? Otherwise, I can always go back to finding a job. But there is a lot of experience that I had building a reactor, designing them. I am an engineer, because I did engineering, but I never built reactors. I never knew. I know the process. I know how to do a reaction. I know how to do. But building them from scratch was a great experience. It's a different experience. So I think I can say that I did a good job choosing this. But yeah, that's one of the points that was in my mind, that how do I make a great impact? By taking this path, I think I'm justifying that. Yeah.
Any other questions from the audience? Well, Dr. Hyderkhan, this has been a very inspiring talk. We're all very excited to see where SeaLion Energy goes in the future. But please join me in giving Dr. Hyderkhan a round of applause.
Thank you.
And thank you so much for all of you for coming. Please grab some leftovers on your way out. And also make a mental note that on November 6th, we're going to have Thomas Healy, who is the CEO and founder of SeaLion Energy. He's going to be giving an entrepreneurship talk right in this room on November 6th.